In this video, we will talk about Rapid Spanning Tree Protocol. RSTP, Rapid Spanning Tree Protocol, that is an improvement over the original Spanning Tree Protocol designed to speed up the process of network topology changes and enhance overall network performance. So RSTP, guys, reduces the time it takes for a network to adapt to changes such as a switch failing or a new switch being added. So it can converge in seconds compared to the minutes required by the older spanning tree protocol. And RSTP is backward compatible with the spanning tree protocol, meaning it can work with networks that still use the original protocol. However, for optimal performance, RSTP should be used throughout the entire network. Also, Rapid Spanning Tree introduces some of new port roles and states which help in more quickly and efficiently determining the best paths and dealing with network changes. So overall, guys, RSTP helps to maintain a loop-free and reliable network while improving the speed at which it recovers from failures or changes. So with RSTP, the issue of spanning tree protocols late reconvergence is resolved. There are mainly 4 port roles in RSTP, and they are root, designated, alternate, and the backup. So the root port is the port on a switch that provides the lowest cost path to the root bridge. So each non-root switch has one root port which is used to forward traffic towards the root bridge. So the root port is in forwarding state, which means it forwards frames and participates in frame learning. On the other hand, designated port, that is the port on a network segment that has the lowest path cost to the root bridge. So it is responsible for forwarding traffic to and from that segment. So each segment has only one designated port, and this port is also in forwarding state. It ensures that the traffic can flow freely between switches on that segment. And we have the alternate port, which provides a backup path to the root bridge in case the primary path, the root port, fails. So the alternate port is an alternative path to the root bridge, and the alternate port is in discarding state in RSTP, meaning it does not forward traffic or learn MAC addresses under normal circumstances, and it is ready to take over if the root port fails. And we have the backup port, which is a backup to the designated port on a specific segment. It is a secondary port that can take over if the designated port fails. So the backup port is also in discarding state and does not forward traffic or learn MAC addresses. It ensures redundancy on a segment where there is a risk of a designated port failure. So guys, in summary, root port, that is the best path to the root bridge, designated port, that is the best path on a segment, alternate port, that is a backup path to the root bridge, and backup port, that is the backup to the designated port on a segment. As I told you before, guys, RSTP is designed to improve convergence times in network topologies compared with the old spanning tree protocol. So RSTP introduces several port states to manage the role and function of each port in the network. First of all, we have discarding port state, and that is the port does not forward traffic and does not learn any MAC address. So it is used for ports that are either not in use or are part of a redundant path that is not currently active. So it prevents loops by discarding frames and does not participate in frame forwarding or learning. We have the learning port state, that is the port does not forward traffic but learns MAC addresses from the incoming frames, and this state allows the port to build the MAC address table. Okay, so learning state prepares the port to transition to the forwarding state by learning and updating the MAC address table. And we have the forwarding state, that is the port forwards traffic and learns MAC addresses. So it actively participates in network communication and can send and receive frames. So this is the normal operation state, guys, where the port is fully operational and involved in passing traffic and learning the addresses. So let's do a quick head-to-head between STP and RSTP. So first of all, from speed perspective, RSTP offers much faster convergence than STP, which reduces the network downtime. From complexity perspective, RSTP simplifies the state and role management compared to STP. From port roles perspective, RSTP introduces additional port roles like alternate and backup to enhance redundancy and quick failover. From compatibility perspective, RSTP can coexist with STP but operates more efficiently with all RSTP networks. So RSTP, guys, improves on STP by reducing the time required to recover from network changes and failures, making it more suitable for modern networks that require higher availability and deep performance. So if you just want to configure RSTP, here is how you can achieve it. The only command that you need to use is in config mode spanning tree mode followed with rapid PVST. Alright guys, thank you so much for listening to me and see you in other sections.